information on straight line graphs. So we have been looking at the equation of a straight line, how it's used, how we find it, how we can draw straight lines from the equation. We need to have a set of axes, and each straight line is defined by two features: its gradient. So these graphs will have the same gradient but different y-intercepts. These lines are parallel to each other. They have the same gradient, so they are parallel. And then the y, where it crosses the y-axis, the y-intercept. These graphs here, they all have the same y-intercept, but they have different gradients. If a graph has the same gradient and the same y-intercept, then it's the same graph, the same line. So we've been looking at different ways that we can identify these features. We can only put it into our equation when our equation is written like this: y equals mx plus c. When we have this, the m and the c are the parameters. They get replaced by the numbers that make each line unique. So, if we have y equals 3x plus 2, this has a gradient of 3 and a y-intercept at 2. If we have minus 2x minus 3, the gradient is minus 2 and the y-intercept is negative 3. So it's very straightforward when we have it in the form y equals mx plus c. We have, however, been rearranging equations in a previous unit, and sometimes we need to do that to be able to gain the information we need from the equation. So if we have 2y equals 6x minus 3, we can rearrange this by dividing both sides by 2 to get y equals 3x minus 1.5. So this graph has a gradient of 3 and a y-intercept at minus 1.5. So sometimes we need to rearrange. Let's try another example. Y plus 4x equals 2. Take 4x from both sides. So the gradient is the coefficient of x. So the gradient is negative 4 and the y-intercept is at 2. Another one. 3y minus 5x equals 10. So we start by adding 5x to both sides. Then we need to divide both sides by 3. So we can call this 10 thirds plus 5 thirds x, or we can change them into mixed numbers. So this gradient is 1 and 2 thirds, because that's the coefficient of x, and the y-intercept is at 3 and a third. Just a quick recap. Finding the gradient from a line, change in y over change in x. We make sure we read from the graph so we get the right scale. So in this case, we've gone along 2, 4, 6, 8, and we've gone up to 4. So it's actually 4 over 8, but we get to the same thing of a half. Change in x, change in y. One's gradient of minus 2. and it's the same wherever you check on the graph. So we've spoken about parallel and we've spoken about rearranging equations. Using your knowledge, which of these equations are parallel to each other on a set of axes? Find which ones are parallel. The answers. So we need to start by rearranging the equations so we can find the gradient of each. Pause just now if you got the rearranging incorrect for any of yours so that you can correct your answers. Now, which ones are parallel? These ones all have a gradient of 2.